It is no surprise that physics problems can sometimes be very confusing. So confusing, in fact, that you don't even know where to begin and you get frustrated and you give up altogether. However, I can guarantee you that physics problems are no different than any other problem, and in this video, I would like to show you some strategies for how to approach them and solve them. First of all, every problem contains some information that is given to you, either explicitly as a number or implicitly in words. The first step is to be able to extrapolate all this information and tabulate it. That is, write it down clearly with the appropriate units. This will give you a clear idea of what is given to you and what these quantities represent. The second step is generally to draw a picture or a diagram of the problem. The diagram should not contain detailed drawings of the objects in the problem, but rather give you only an idea of where these objects are and how they're interacting with each other. You want your diagram to be clear enough to elucidate the nature of the problem, but not so detailed to the point of being cluttered. Instead, try to strip the diagram of all the unnecessary information such as the shape of the objects. Draw the objects as point and denote all the vectorial quantities by arrows. The third step is to choose a coordinate system with appropriate orientation. The XY coordinate system is just a convenient way of giving the positions of the objects, so we have the freedom to choose its orientation. Making the right choice can sometimes greatly simplify the problem. For instance, for the case of this inclined plane, choosing the X and Y coordinates in the standard orientation leads to unnecessary complications with the angles. In this case, it is best to align one of the axes with the hypotenuse of the triangles, as this will reduce the components that you work with. Once the initial setup has been completed, we can move on to the next step, using the equations to solve for the unknown quantities. This is somewhat a skill that is acquired with experience, as it is not always clear right away which equations one must use. But a rule of thumb is, in my opinion, to use the equation or set of equations that seem to relate the given quantities. And this brings me to the next point, which is understanding what the unknown or unknowns are. It might seem obvious to you that you will know what you're solving for, but that's not always clear. One way of resolving this issue is to look out for keywords. If you're asked to find out how fast the object is moving, then you're certainly looking for velocity. If you're asked to find out how long it takes for the object to fall, then you're looking for time. When solving an equation, students are normally tempted to plug in the numbers from the start, as we feel more comfortable with numbers than with variables and unknowns. But this is a big mistake, because once you plug in the numbers, all you have is an equation with a bunch of decimal values on both sides, and it's very easy to forget what these numbers represent and what the units are. A good rule of thumb instead is to solve the equation completely for the unknowns and then plug in the values at the very end. This will make it easier to trace your steps and make sure that you have performed your operations correctly. Once the equations have been solved, you have to check your answers and verify that they make sense. First of all, you want to make sure that your answer has the desired units. For instance, if you're solving for time, your answer should be in seconds or minutes or hours, but not in kilograms. Secondly, you must use your judgment in determining whether your answer makes physical sense or not. For instance, if you were trying to calculate the speed of an ant marching along and you obtained 344 miles per hour, then you're clearly doing something wrong. Even the ant is telling you that here. The lesson to learn here is that you should not accept your answers at face value, but rather reason as to whether they make sense or not. To summarize, here are the 5 steps that you should use to solve physics problems. I can guarantee you that if you use this strategy, your problem-solving skills will improve immediately and your life will be a lot better. Thank you for watching. I hope you enjoyed the video. I'll see you next time.